So hi everyone and welcome to Casper's second workshop as part of the Smart India Hackathon. Today we'll be showing you how to execute NFT transfers, query the balance of, owner of, and total number of NFTs minted. Then we'll build out a front-end application to interact with our NFT logic. But before we do that, Karan is going to take us through and show us the details on building smart contracts on Casper. So Karan, take it away.
Hello, guys. My name is Karan. I'm Karan. I am a software developer here at Casper Labs. I've been writing smart contracts on the Casper platform for about 2 years now, or something close about. So today, basically, what I would like to show and walk you guys through is the process of writing a smart contract, what it means to write a smart contract, and some basic fundamentals around smart contracts. That way, when you look at the NFT code, when you start building the front end around the NFT and start interacting with the entry points of the contract, or basically what we call the entry points are the functions of the contract, you understand what's going on underneath the hood. So with that said, what I'm going to do now is share my screen. And this is a contract that I had previously written. We're going to basically repeat a lot of this code, but to show you what we're doing right now is we're going to have a contract that has a purse. This is a fundraiser contract essentially. So what we're going to do is write an entry point that manages a purse, allows you to donate to that purse, and this contract will basically keep a track of which account on the Casper network is donating how much or how many times they've donated to this fundraiser contract. So to begin with, let me just walk everyone through how to start writing a contract. So we provide this utility called Cargo Casper, which allows you to basically set up your project. It'll automate the setup of the process of setting up your project directory. So I'm going to call my project donation, or let's call it fundraiser. Okay. And so we'll now open it in my IDE. Open the Casper fundraiser. There we go. Okay. This is my project. This window. Okay, cool. Okay, clean project. So when you run Cargo Casper, what you'll see is you'll find two subdirectories. One is the contract. This is the smart contract. This is the folder where we'll be writing the smart contract. And these tests are tests that we will write to ensure that the workings of our contract are the way we expect them to ensure that maybe they'll help eliminate bugs and basically make sure that the contract functions in a way that we expect it to. You'll see that this attaches just something my ID is running through. Okay, so you'll see that the cargo toml, which is basically your dependencies and your manifest for this project, already comes kind of pre-written for you. So it's already imported the two most fundamental libraries that you need to import. One is the Casper contract, and the other is the Casper types. The Casper contract is basically the API you need to write a smart contract, and then the types crate over here basically lets you access the types that are specific to the Casper platform. I'm going to have to update my. Everyone can see my screen, right? I hope. Just sound off if
yes.
Okay, cool. Thank you. We just need to update the toolchain, which is what we're going to do first. So let's do that first. I'm just going to go into another project of mine and copy the toolchain from there. So here. And then we're just going to paste this here. Makes life a little simpler now. Okay, cool. Alrighty. Okay. So now this main.rs is where we're going to write our smart contract. You'll see again that it's come pre-filled with a hello world type logic. We're going to get rid of most of this, so let's just start by doing some cleanup over here. These errors are there, but we'll get to those later as well. You can see it's done some basic imports for us as well. So let's start with lines 1 and 2. We'll go from the top down. So you'll see that we've asserted these two flags. One is saying no stood, and the other is saying no main. So what is the no stood? For those, most of you may know this, But a lot of the code that we use and we use on our normal, on our normal local desktops or PCs or laptops, help and use the standard library. This is because an operating system has that library, so code that runs on our, on our normal computers can actually use the standard library. Now, because on the Casper platform, we have a pseudo Turing complete execution engine, or rather a virtual machine, you don't get the standard library. The standard library won't be available to you. So if you try to compile without this no stitch flag and started running the code in a Casper execution virtual machine, you'll see that the code actually won't run because it requires the standard library. So because we are going to be operating in an environment, in a runtime environment that doesn't provide the standard library, we're using this no stitch. Another thing is the no main. Again, this is something that we see in a lot of like just binary code, right? There's always like the main function, which we use as like the primary like entry point to the code. Again, we're not going to be using that. We're actually going to be writing our own, which is called call here. So we're basically telling the compiler, yeah, we know that there's no main function, but that's by design. We want it to be like that. And again, you can see we need to explicitly import the std alloc crate and the alloc string as we're in a no-skid environment, which is why we're using this. Okay, cool. So with that said, we're just going to start writing the code to begin with. So like I said, we want to write a function that will accept token and will act as a way for people to donate as part of the fundraising project. So we're going to start with this hash no mangle. This will be like the first thing you write in on top of any entry point that you write, and I'll come to the keywords as the moment I'm done writing them. Okay, done. Okay. So what does this no mangle flag mean? The no mangle flag is basically telling the compiler that at the time of compilation, because this Rust code that we're writing right now will eventually be compiled to WASM. If we didn't provide this no mangle flag atop our function, the compiler can take liberties with how it wants to represent the name of this function within the WASM bytecode. So it can change it into something that may not be human readable. Now, the way the oh my god, what is up with my mouse today? The way smart contract execution works is first you actually have to install the smart contract and define the functions within the smart contract. So as part of installing the smart contract, what happens is parts of the WASM are actually extracted out. And so this no mangle flag, it ensures that this donate word within the, like this donate human readable donate, is preserved within the WASM bytecode, and it doesn't get mangled essentially. That way, when we install the smart contract, the installer of the smart contract, or rather the virtual machine that installs the smart contract on the Casper platform, knows what part of the WASM bytecode to look at. So it looks at, oh, there's this human readable string called donate within this WASM bytecode. This is the WASM I need to extract for this particular function within the smart contract. By the way, if anyone has questions as I'm going through this, please feel free to ask them. So in case there are questions, please feel free to ask. Okay, cool. So how do we write this? So we want to take in a account key. That way we know who is donating to us. So what we're going to first say is, okay, let donating account key. To accept arguments from the runtime, we provide this thing called runtime get named arg. So I'm going to call it get named arg over here. Right. And now we can specify a name for a runtime argument, which is what I'm going to do now. And I'm going to call this, say, account, or let's call it donating account. Okay, let's just call it account. It will be easier when it's on the other side of things. Okay. And this is going to be a type key. A key is basically an identifier, and there are multiple different types of keys. So let's see if you can step into the definition, which I'm struggling to do here. Hang on, let me just make sure. Okay, I'm just going to show you guys the actual source code itself. So here, let me go to this key. So this is what I meant earlier when I said key. So you can see that there's this notion of a key here called account, right? So the way the Casper blockchain works is there's like a shared database, right? It's like this huge database, which is essentially what we call global state. So any data that you write as part of executing your smart contracts, and this could be things like NFTs or something like that, must be stored underneath some key. So all accounts are stored underneath the key account. Like, so each account has this account key. So all accounts are stored underneath the account key. There's another one for hash, which could be a smart contract, a URef, which I'll get to later. So essentially what we're trying to say is, okay, there's going to be an account key that comes in, and we're going to try and accept that account key. Whoops. Okay, going back here. Okay, so then this is the donating account key. Okay, and so basically what we're going to say is we're going to check that first off that the thing we received is actually an account. So let's do that. So if let, and this is Rust syntax, this isn't anything specific to our platform, but this is how you can do something like this in Rust. Essentially, because a key can be one of, say, 8 different things, right? We only care about the 1 out of the 8 cases. So this is a way to just focus on the one case. Equals donating account key. Okay. And so what we're going to do here is we're going to fetch it a purse, which we haven't created yet. So what we're going to say here is to do return purse here, right? But otherwise, if it's not a key that we expect, we're actually going to throw an error. So first for that, we're going to actually have to write our own error. So let's do that now. So pub enum error. Do this. And so basically what this error over here that I'm writing now are basically our custom error codes. That way, also, by the way, if people are asking, please feel free to unmute and ask, because I can't see chat. So if people are asking questions in chat, I would rather you unmute and ask the questions, because I can't read the chat as I'm going through this process. Okay, so what we're going to do is we're going to say, so we're going to create our first custom user error invalid key variant. I'm going to call this 0, right? And as we add more errors, this number might grow. So, you know, if you look at one of our NFT contracts, which I can show you here, and if I go to the contract here, source main error, you can see we have close to some 106 errors here, right? So what this allows us to essentially do with these errors is basically when the contract fails, it'll return a specific error code that has meaning to us, so that when the execution of the contract fails, if it does fail, we know exactly why it failed, right? So if I go back to my code here, if I get the custom user error 0, I know that the invalid key variant was raised, right? So then I can like kind of be very surgical and very precise. I know exactly where in my code that error was raised. Okay, moving on. Okay, so we now have our error that we wrote. So what we're going to do is we're basically going to say runtime. There is this function called revert over here that basically is like a panic of sorts. Basically, it's going to say, okay, stop the execution and roll back any kind of modifications you made to global state, essentially. So we're going to revert with the error invalid key variant. That's what we're going to do here. Okay, cool. So for now, we've got the basics of our donate function ready. We're missing a purse, so we need to actually create a purse. Now, there's many ways to create a purse, but because a purse is something that handles token, and token has a monetary value, we have to be very careful about how we manage purses. Purses are restricted to something called access rights. And so the access rights are taken from something called the named keys. So named keys are found on 2 objects within the Casper system, essentially. So there's this account over here. So an account is something, represents me or you. And so you can see that there's this account structure here, and you can see that it has its named keys here. Named keys are basically, and if you can actually just step into it, you can see that they're basically a mapping of a string name to a key, and the key is the same key we were looking at earlier. Okay, and so what happens is at the time of execution, these name keys are looked up, and the access rights, essentially, do you have access to this purse is based on whether or not the purse, which is a type of URef, which you can see here. You can see that it's actually, this main purse is actually called a URef. So we're going to basically check if the URef is within this named keys. Now we want it to be within the contract's named key. So what we're going to do is within an entry point, we're going to call something called, we're going to make another entry point. So again, I have to write the no mango flag over here. Basically, again, reminding the compiler to not change the name of this function when it compiles it to WASM. So we're going to call it init. And this will kind of like act as like a way for our contract to initialize things, right? So we're first going to do, what we're going to do is we're going to make that donation purse. So we're going to call it donation purse, okay? Which is essentially a URef. And we're going to need the system. We're going to do create purse. Okay. And what this will do is it'll create a purse for us. Now, what we need to do is persist it to our, or rather this contract's named key. So that way, the next time around when the contract needs to either transfer out of this donation purse or send this donation purse to somebody else to transfer into, it has the access rights to do that. Essentially, it has the permissions to do that. So we're going to persist it to our name keys by using something called put key. So what we're going to do is we're going to call runtime put key like this. And we're going to call this donation, right? Because this is the donation purse, and we're just going to convert this into a key. If we just do .into, that's more than enough. Don't know why it's doing this. Okay, that's fine, I guess. Okay. Any questions so far? We can take a break. I know I've given a lot of information there, but if anyone has any questions, again, feel free to pause. Now, I had said at the start of this that we want to be able to track how many times a single person has donated to this contract, not the amount that they've donated, just how many times they've basically called this function here to donate to the contract. So for that, we want something like a map, right? Like this account to these many types. So for that, we provided a capability called dictionary. So we're going to create a dictionary. The word dictionary is the same as it is in the word the same in Python. So Python also has its notion of dictionaries, but they operate in subtly different ways. So don't think they're equivalent, even though they have the same name. Anyways, so what I'm going to do is I'm going to first create the dictionary. So we're going to use the storage function or the storage part of the contract API, and we're basically going to write new dictionary. And we're going to call this new dictionary the ledger. Sure, like this. Okay. So now what this will do is this will create this init function, right, which is like kind of like the initializer for our contract. Will basically create a purse. It will persist the purse. That way the contract has permanent access to this purse. And we're also going to create a new dictionary titled the ledger. That way, as part of donations to this contract, we can track how many donations were made by how many accounts. Okay. So now we can come back here. So now that we have the purse, right? So let's do this. So what we'll do is we're going to say as part of just donating, we're just going to update the amount of donations you made. There is a bit of a flaw in the logic, but for now, for the purposes of this demonstration, don't worry about it too much. So basically what we're going to do is we're going to say, okay, this is a account because we're only accepting donations from accounts currently, right? We could actually extend this model to accept donations from other contracts as well, but for now we're going to just focus on accepting donations from accounts. So what we're going to say is, okay, we're going to update the number of donations this account has made. So what we're going to say is let number of donations, right, equals storage dictionary get. Okay, this dictionary get function basically lets us retrieve well, you know, it's like we're just going to get the value underneath in this dictionary. So we're going to say key account, right? And just give me 1 second. I need to make sure that I'm getting this right. aha, okay, it's just a string. I'm just going to copy this function over here for the sake of time. Okay. All this function does is it basically looks up the dictionary value and then just updates it as it needs to. So that's what we're going to do. As you look at it, source says, okay, get me the seed URef, get me the dictionary. If there was no value, then this is a first kind donation, so just put the value 1 because this is their first time donating. In the sum case, okay, they've donated previously, so then update it by calling dictionary put, and then updating the current number of donations plus 1. That's essentially what we're doing here. Okay. Okay. So then we can use that function here. So instead of this, we're just going to say, what do we call it? Update ledger of record. And what we're going to say is, just making sure that I have this right again. Okay, yes. What we're going to say is toString, because as you can see, this function over here takes in a string value. So basically, when we can look at the API of this as well. Can I look at this API? No, but we can just look at this over here. Dictionary. There we go. So this is the same function. So you can see it takes in the seed URef, which is basically the access lock around the dictionary itself. And then you can see it takes in an item key, which is of the type stir. We look at dictionary get, you can see it takes in another seed, the same seed URef, and then it takes in an item key. So whatever is underneath the item key. Retrieve value stored under dictionary item key in the dictionary accessed by the dictionary seed URef, essentially. Okay, so going back to our code that we're writing right now. So dictionary seed URef, we've got the item key. Okay, so all of that, more or less, sorry. Okay, so then we've done the update of the dictionary. So we're updating the ledger record as we go and as we continue to proceed. So what we're going to do now is we're going to return the purse so that the person calling this donate function gets a purse that they can transfer to. Okay, so now what we're going to do is we're going to say runtime return rect, which is basically the return function. And first we need the purse. Let's go get the purse first. So let donating purse, right, which is a URef, as we can see, equals runtime get key this time around, right? Because here we did put key. Now we just need to get the value underneath that key. Okay, and we're going to say donation, because that's what how we saved it. Now this I don't think is. Don't like how my IDE is not working around. Okay, this is so strange though. Okay, fair enough. We'll just have to work through the errors when we get to them. Okay, so this get key. So we can just keep looking at the source code essentially to see if we're on the right track or not. So we're going to look at. Okay, so this gives us an option of key. So we need, and remember that a key could also be a URef. So what we're going to do is we're going to basically turn the option of the key and try to turn it into the URef. If we can't turn it into a URef, we're basically going to error out essentially. Okay, so this gives us an option of a key. So we're going to say unwrap or revert with. So this lets us revert with a very specific error. And so what we're going to say is we're going to say missing donation URef equals 1. So that way, if we see, you know, a user error 1, we know why that's happening. It's because we don't have a handle on this get key. So when this get key returned something, it returned actually nothing. It returned the none, which means that this step was never called, which basically means that the contract is in a state that it can't essentially recover from, which is bad. So we're going to return with error missing donation URef, right? So now it's a key. We're going to turn this into right. Now this will give us our donation purse URef. Okay, so donating purse. Now, if you look at a URef, right, and if we step into what a URef is defined as over here, you'll see that it has this address, which is the address of the URef, and certain access rights. Now, an access rights is one of three things. And there's obviously there's no permissions, there's the read, write, and add, right? So what it means is if you have a URef with read permissions, basically all you can do is read the value underneath that URef. If you have a URef with write permissions, it means that you can write under the, like essentially you can modify the value of the URef. If you have add permissions, then you can add to the value underneath the URef, right? And so then you can start building any kind of combination. So you have read write, add write, and then all the permissions, which is read, add, write. Now, the problem is, if we just gave away this purse as we're currently doing, we would be giving it away with read, add, and write privileges, which is a problem. Because what it means is once we gave this purse away, like as part of this one-time return call over here, we're actually giving it away with the write access, like the WRITE access rights alongside it, which means a person accepting this purse would get those write access with them, which means they could modify the value underneath this purse as they wanted to, which means say that, you know, a lot of people who were nice people donated and then they raised, say, you know, like $100 worth or like 1,000 rupees worth or some value in terms of like actual money, right? If they had the right access on this purse, they could actually like drain the purse themselves. But essentially, they'd be able to steal all the money underneath this purse, which we want to prevent. So how do we prevent that? Well, we know that we only want people to add or like donate, right? Which is a very additive process. So we only want people to be able to add to this purse. So we're just going to say into add, which basically means this purse that we're giving it, you only get the add permissions alongside this purse. So that way they can only add to the purse and they can't essentially subtract from it is the point here. Okay, so that's more or less how, you know, so we've got our two functions set up here. They'll do what we want. There'll probably be a few errors there, which we'll probably have to sort through. But now we actually, so this part of the code, or more accurately, this part of the code is essentially what forms the smart contract, right? We've got kind of like the meat of the smart contract, or rather the skeleton, right? Now we just need to kind of like create an installer for it. So that way, when we compile it to WASM, send it to the network, we can actually install the contract and then use it later on, right? So that's what this call function will do. It'll act as the installer for our smart contract. Okay, so let's just start by looking at how we create a contract, right? So let's say let underscore equals storage new contract. I believe it's a new contract. Let's check here again. Okay, it is in storage. Okay, so let's look at this function and see what it says. Create a new contract stored at key hash at version 1. You may upgrade this contract in the future. If you want a contract that is locked, i.e. cannot be upgraded, call new lock contract instead. And then you can see it talks about the various arguments that it means. If named keys are provided, we will apply them. If hash is provided, we will put the contract hash in the current context named keys, and the same thing with the URef name. But you can see it takes these things called entry points, right? So recall at the start, right, I was talking about why we need this no mangle flag. It's essentially to prevent this name donate and this name init from changing once a compilation takes place. Well, that's because we need to define the entry points here. So let me just define the first entry point, which is the init entry point. So I'm just going to call this init entry point. Okay, and then I'm going to do entry point new. Yeah. Okay. And so we're going to give it this. And if you look at the, again, because my IDE isn't working today. Okay. Right. So we look at the constructor for this. So it takes in a name. It takes in certain, like whatever arguments we need to provide it. What does it return? The type of access and basically the entry point type, right? So for our first entry point that we call init, we're going to give it the name init, right? So init over here like this. So this is the key pointer. This is kind of like ties it all together. Because we've defined an init entry point with the name init, what happens is as part of installing this contract, it'll look at this string here and go, init. I'm supposed to look in the WASM bytecode for something called init. So it'll look at the WASM bytecode for this and see, okay, this is called init. This is the WASM related for this init entry point. Basically what happens is as part of installing a contract, we create a table of entry points named to the WASM to be called or the WASM to be executed for each of those entry points. And so this is the mapping that we're doing. So the name to the WASM itself. It also takes in a set of parameters, but because our init entry point actually doesn't take any runtime arguments, like unlike our donation entry point, which does, we don't need to provide any parameters here. It doesn't return anything here either. So, our return type will be null or unit in the case of Rust. So we're going to say CL type unit like that. And then we have to now define the type of entry point it is. So I believe that's what it is. Let me just check again. Entry point access. Okay, so we need the access. And yeah, so we're going to keep these as public, and then entry point type is contract. Yeah. Okay, so entry. Just give me 1 second. For the sake of getting things right, I'm just going to copy this over here. Cool. Okay, so that's one entry point that we write. Now, because we have a second function here, we're going to write another function. So we're create another entry point. So we're going to call it donate entry point. And this follows essentially the same process. So we're going to say entry point new donate, right? And then this time we're going to change things around. Because this thing takes in a key, we're going to pass in parameter new, the name, which is account, and then the type of it. So CL type key, because we're expecting this over here. So say we were expecting something like, say, a public key like this, we would change this to be public key like that. But because it's key, we're going to make it key. Okay. Then we do actually return something here, so we're going to have to change the return type. So we're going to say CL type of URef, because we're returning a purse, which is of the type URef. And then the remainder of the two are essentially the same. Cool. All right. So now we just have to say let fundraiser entry points is entry points. And this has to be mutable because we're going to actually modify this value, right? And so then we're going to do fundraiser, and we're going to say add entry point the first entry point, which is init over here like this, and then another one at entry point to donate. Okay, very cool. So now we've more or less finished. This is like the last few bits. So now we need the fundraiser. This gives us the fundraiser contract hash, which is the primary identifier for this contract. And then we'll get a fundraiser contract version as well. And then what we're going to do is we're going to give it the fundraiser entry points. And what were the other arguments to this? Let's go back here. Oh, whoops. It's okay. We can just look at this here like this. Okay, so it takes in the hash named keys. Well, we're not giving it any named keys here, so we can put this as none. And then we want to say some string from fundraiser contract package, and then some string from fundraiser access. Okay. And that's essentially it. This is how we would, write a smart contract. We could then compile this to WASM and then send it to the chain and then, see if it worked or not. We could also write tests. However, because this particular IDE of mine isn't working, what I will do just to show you, just to kind of demonstrate, for demonstration purposes, I'll just walk you guys, show you what a test would look like, right? This should be able to install and donate. So again, the contract is very similar here as well, right? So we're creating the contract with some entry points. There are 2 additional entry points here, but again, it really doesn't matter. Then we've written some other bits of code, and then we've basically written a test here to actually execute this. And I'll show you how it looks like, because there's only one test here. So if I write make right, this will now run. This should then, it'll take some time, but it'll compile the WASM and then actually run the WASM in the same way that the WASM would run if you were actually deploying this to a Casper blockchain and we were executing it there. So whatever bugs would have occurred or any runtime errors would have occurred if there were bugs in the contract, the same bug should ideally appear here and this test should fail. So if this contract is working correctly here, then our tests will pass, and then we would know that our contract, if we deployed it to the Casper chain, would also work in a way that we expected it to. That's the beauty of writing tests. Because we're a little bit short in time, I won't be able to get into writing tests today, but what I will show you guys before I hand it back over to Dylan is our documentation over here. So this contract that I wrote is actually described in developers. Here. So if you go here and you look at a basic smart contract in Rust, you'll see that it is essentially the same contract. And this document is basically what I kind of sped through a lot of things in the short amount of time that I had. But this same document talks about the stuff that I was talking about earlier, but in a lot more detail. And you can see that we have a full-fledged documentation about how to write on-chain code, the various types of on-chain code, again, a lot of which I couldn't get into today. But please feel free to read this documentation. If you have any issues or there are things that you're unclear on, please raise an issue on Casper Network. Yeah, so if you see anything wrong with our documentation or you would like to add to our documentation, please feel free to come here to the issues page and then raise a ticket here. Then we will, we'll triage it, see, and then try to work on it essentially. And by now, my code is almost about to be finished compiling. So let's just give it another second. Almost there. Oops, it didn't work. So let's see why it didn't work. Missing argument 2. Okay, so very interesting. Let's see. This will be a nice exercise. So contract installation request, that's fine. Miss something here. Okay, so let's see. So it says the missing argument. So basically what this error means is we were supposed to give it a runtime argument. It didn't get that runtime argument. So now it's complaining at us saying, hey, I expected this runtime argument that wasn't provided to me. So clearly something has gone wrong. So let's stop for a second and see where it could have gone wrong. So funds raised. So let's look at this funds raised because I think that's the one with the missing. No. Okay, interesting. Donation account. Let me see. This is the one that's missing something. Okay, no, get named. Okay, so maybe let's look at the contracts themselves. Maybe we're missing something here. There's one parameter for get donation count. There's one parameter for donate. Get funds raised. It's completely empty. This is interesting. Okay, so let's go to here again. So let's see if we're making sure that we're sending everything. Yep, donating account key, donation amount. So this is the purse that we got back. So this is the, and then you can see that we're doing another transfer over here. So we're, this is how we can donate to the fundraiser contract essentially. But yeah, the test isn't working for some reason. Interesting. So let's see. I believe it's this. It is this. Yes. Right, so this init function was actually expecting a runtime argument that wasn't needed, which was causing the test to fail. So if we recompile this, it still failed. Excellent. But is it the same error? Missing argument. Wait, I believe I need to do make build contract first. Okay. And it still failed. Interesting. Let's see. System create first. This was fine. Interesting. Yeah, let's see. You should be able to actually debug this. I don't know why it's taking so long. Here's what we can do to debug what exactly is failing. We'll start commenting bits out until we see which execution is actually failing. So what we can do is we can go up to here, right? Because that's where the first request is happening. So now all we're trying to do is just see if we can just install the contract by itself, right? So let's see if we can just install the contract first. Okay, so that part worked. So let's start now adding things back and see exactly which part of the code is failing. Okay, so the contract hash. So now we're going to make a donation request and see if that donation request works. Okay, so let's do that again. Okay. So is this missing argument 2? Okay. So it's on the donation bit. Okay. So now let's look at so we're sending 3 args here to this donation code here. So let's see if it's getting 3 args. So we sent named arg, named arg. Okay. So this part looks good. And then entry point donate. Okay. And so let's look at the donate entry point on the actual contract, which is over here. Sorry. Okay. So donate. It's a donating account key. So maybe we got the name wrong. Could be. Sometimes even if you get the name wrong, that will still because it's looking in a buffer. It's like it's looking in a map of string names to actual values. So even if we got the name wrong here, but we still provided the correct runtime argument, it would still actually fail. So it's worth checking to see if our donating account key. Okay, that looks correct on this side. Let's look at donate over here. Donating account key as well. And then donating. So as you can see, it has like this thing donating account key to the actual value itself. So if we got this wrong and this correct, it could still actually still fail, essentially, is the point. Okay. And so if we go back here, okay. And so let's look at the entry point definition. Maybe sometimes you can see that over here. Let's see. Okay, so the args seem to be here as well. Let's see this again, terminal. Let's go back to the test. Maybe we missed something in the test. Okay, so let's see. Let's have default account address, session file is donation, sure, which is this file over here. And it expected the fundraiser contract hash, which is a type key. It expected the donating account key, and it expected the donation amount. Okay, so let's look at the test again and make sure we've gotten everything right here. So we're giving it the contract hash. I believe this might be the issue because we're sending in a contract hash and it's expecting a type of key. So maybe this is what's going wrong. Okay, so let's just change that bit of code. So this is contract hash. So what we're going to say is let contract key, so type key equals contract hash dot int. I'm just going to make this one change. And we're going to send this contract key like that. Okay. Now let's see if this works. Oh, it still didn't work. Interesting. Missing argument. Okay. Here. See, I think it's the same issue here. So in our test, I believe this is Fundraiser contract hash. So we made a mistake here of not getting this. Oh, no, wait, this is the wrong one. Sorry, donate. Here you can see that this is actually fundraiser key. So this is the same point. This is the point I was making earlier. Because we got the name wrong, it couldn't find the particular runtime argument. So it was like, well, whatever you sent to me, I found the things you sent to me, but they weren't what I was looking for. So we're just going to change the string value and see if it still errors out. Okay, let's try it again. And it still fails. Interesting. Same argument to fundraising key. Okay, and now let's look at this. So here, Okay, so I can't for the life of me figure out what's happening here. Fundraiser key, donating account key, and then the donation amount. Hmm. Let's see. Contract case over here. This is fine. Main.rs. Again, let's just try and make sure that we've got all of our bearings correct. So this says fundraiser key, and this says donating account key, and then this is amount. So this says amount, but what we're providing it here in the test is donation amounts. Let's change this to just amount here like that. Now let's see if this works. Terminal test. And it works. Um, so I'm going to stop pushing my luck and pause there. But that's essentially the basics. And thankfully, there were errors, so that way you got to see how the test framework works, or at least how you can go around debugging your tests to make sure that they're working the way that you expect it to, right? But that's a small deep dive into our testing framework, I guess. But that's essentially it for me. I'm going to hand it back over to Dylan at this point, so that he can take you guys through building a front end over the NFT and then interacting with the NFT contract as well. So over to you, Dylan. Thank you.